All right, so I just thought we'd look at the 2.1 homework, see what's going on. Hopefully you guys can hear me. The last video I made had no voice, no audio. All right, so let's check out the 2.1 homework where we're looking at average and instantaneous rate of change. So this first one, find the average rate of change of the function over the given interval. So the average rate of change, remember, is really just change in y over change in x. So essentially using function notation, that ends up being, this one's an f, so f of t2 minus f of t1 divided by t2 minus t1. And this is just the slope formula, change in y over change in x. So in this case, notice this is an interval. So the start of my interval is pi over 2, and the end of my interval is pi. So I'm just going to do the first one here, and you guys can do the second one. All right, so let's just plug these things in. So we've got f of pi minus f of pi over 2 divided by pi minus pi over 2. So I'm plugging this into 9 plus sine. So there's our f of pi minus 9 plus the sine of pi over 2 divided by pi minus pi over 2 would be, well, pi over 2. And now I'm moving to the top of the screen. All right, so let's see, sine of pi. So pi is this one, which is the point -1, 0, cosine sine. So sine is 0 here. So we have 9 plus 0 minus 9. Pi over 2 is the one here on top of the unit circle. So that's the point 0, 1. So our sine is 1. And then divided by pi over 2, which gives me 9 minus 10 over pi minus 2, which is -1 over pi minus 2. And however you want to think about this, how about if we do the times 2 over 2? That would be -2 over pi. Essentially, it's just flipping it up, right? So our answer to this first one is going to be -2 over pi. And again, that's just the slope of the secant line, change in y over change in x, where the starting point is pi over 2 and the ending point is pi. So we're just going to put in -2 over pi somewhere right here. So -2 over pi, and it should be fine leaving it like that. So the second one is just very similar. Just it's always, the starting point, ending point. So you would do f of 3 pi over 2 minus f of -pi over 2 divided by 3 pi over 2 minus the -pi over 2. All right, so let's look at the next one. So this one says to find the slope of the curve. Notice this is at a particular point. Don't worry about the limiting value part of it. We'll talk about the word limiting next week. But so essentially just read the beginning part of it. So let's find the slope of the curve at that point and then find the equation. So this is like the one that was on the thing that we did in class today. So again, just kind of ignore that last part. So let's look at this one. And we're still finding a slope, so change in y over change in x. But the thing is, what we're doing, we only have one point. So what we're doing is just kind of thinking of the second point as being h away from the first point. Okay, so the formula that you end up using for this is going to be, I'm going to use f's. So it's going to be f of the x value plus h is just the difference. It's your delta x. It's your change in x. So this is going to be kind of the second point. It's x plus however far away you're going. So f of x plus h minus f of x. And then usually your denominator, well, your denominator in slope is change in x, and that's just what we're calling h. So now what we want to happen is for h to be 0 because it's 1 point. So you don't have 2 points you're looking at. You just, so the distance between these is h. What we really want is for the distance to be 0, so we're just at 1 point. So our x is -2 and our h is 0, but we can't plug in the 0 right now because it's on the denominator. So let's just very carefully look at this. And I'm going to do this one in pieces. I'm going to go ahead and find the x plus h first. So that's going to be x plus h cubed minus 3. So you see we're plugging the entire x plus h in for that x up there. So when you cube a binomial, you can FOIL this out if you'd like, but it does end up being x cubed plus 3, 2x is 1h, 3, 1x, 2 h's, and the h cubed. And then we have the minus 3 at the end. So this is x plus h times x plus h times x plus h, if you work that out. All right, so that's what it would look like. And now we do have an x of -2, so let's plug the -2 in. Excuse me. All right, so this is really f of -2 plus h. So I'm just going to plug a -2 in for the x. And it's going to look like that. And so just be careful with the signs. -2 to the third is -8. -2 squared would be a +4. This will be a -6 h squared. This will be a plus h to the third and a -3. So that's what that's going to look like. All right, so that's the first part. So we got that part. Now let's just find f of x. Well, f of x is x cubed minus 3, but we're going to be plugging a -2 in. So that's -2 to the third minus 3, which is -8 minus 3, which is -11. So now let's go put this together. I always change colors when I move to the top. All right, let's see. So we have f of -2 plus h minus f of -2 divided by h. And I found the pieces. So we're going to have -8. And actually, I think we got a few like terms here we can put together, right? So -8 minus 3 would be -11. Oh, that's the only one. So plus 12h minus 6h squared plus h cubed. And then notice it's minus the f of -2, and f of -2 is -11. So it's minus a -11. And then that's divided by h. And then remember, we want h to be 0. We just can't plug that in yet. So we have -11 plus 11, which goes away. So we have 12h All right, so we have 12h minus 6h squared plus h cubed, all divided by h. Notice everybody on the top has an h. I can factor that out. H's cancel. And we now have 12 minus 6h plus h squared. And what this is the slope of the line between any 2 points on the function, where h is the distance between the x values. Now again, we want h to be 0. We couldn't plug it in before, but we can now. So if we plug in a 0 for h, we're going to get a 12. So what we just found is m, this is the slope. Okay, so our slope is 12, and we can plug that in. But then the second part of this is going to want the equation. So think back to algebra for how do you find the equation of a line. So we like to find the equation of a line using the point slope formula, which looks like this. So this is just the point slope formula. Our x is -2, our y is -11, and our m, I just erased, but I'm pretty sure it was 12, right? 3x squared, 3 times 4 is 12. Okay, so let's just plug this in. Y minus -11 equals 12 times x minus -2. So that's y plus 11 equals 12x. Notice that's a plus 2. So when you distribute the 12, it ends up being a plus 24. And we'll just subtract the 11. And 24 minus 11 is 13. So there is the equation of our line. So 12x plus 13. So now we can just put this in. This was 12. And this was y equals, don't forget the y, 12x plus 13. I think it was 13. Yay. So let's look at the next question. Maybe. All right, so find the slope of this curve at this point and find the equation. So this is the same question. Do notice this one's closer to what we had in class in that it has this extra x here. So just be very careful. I'm just going to kind of write down what the x plus h would look like real quick. Now, do work out the algebra here. I've cubed things so many times. So this is x cubed. There's going to be 3x squared h's, 3xh squareds, and an h cubed. And then over here, make sure you distribute that 15x, that negative 15x. So it's going to look like this. So this is going to be your whole f of x plus h. And you can plug a 2 in then for the x's. Okay, well, let's go ahead and look at another one. All right, so this one says the figure to the right shows the distance time graph for a muscle car accelerating from a standstill. It says use the information in the figure to answer the questions. And the table below lists the coordinates of the points. So what this is distance and time for a muscle car. So if you look at the graph over here, I'm just going to make it bigger real quick so we can see it better. Oh, well, then I kind of lost it, didn't I? There it is. All right, so at time 0, the muscle car has not moved yet, and then he slams on his gas, and you can kind of see some points that they have here. That first point is 6.5 seconds in. So at 6.5 seconds, he's reached 124 meters, and I'm just reading that from the chart over here. And so then at 12.4 seconds, he's gone this many meters, etc. At the end, it took him 20 seconds to go 650 meters. So the first question says to estimate the slopes of the secants from P, where's P? Where does it say what P is? Oh, is P supposed to be Q4? Oh, well, okay. So I guess P is this very last point up here. All right. So we want to find the slopes of the secants. So remember, a secant line is simply the line that goes through the 2 points. So the secant line for P and Q, that looks really awful, but is going to look like that. If the picture was bigger, you could see that better. But let's try to find the slope of that line, okay? So how do you find the slope of a line? Well, change in y over change in x. In this case, it's actually change in distance, right, over change in time. So we want to go, it's the line from P to Q1. So here those are. So on top, we have the change in distance. So 650 minus 124. And on the bottom, we have the change in time, which is 20 minus 6.5. And let me get my phone calculator out real quick. Let's see. So 650 minus 124. Oops. 650 minus 124 is 526. And 20 minus 6.5 would give us 13.5. It says round to the nearest integer, so let's go ahead and divide that. So 526 divided by 13.5. This is approximately 38.96. So nearest integer would be 39. So that means from time 6.5 seconds to 20 seconds, he was averaging 39 meters per second. Okay, so that's what we just found. So 39 meters per second. And I'm just going to this one in. So it said it was 39. Yay. And so it wants me to keep doing this. I don't really want to. I wish we could just run over to part B. Okay, so from P to from the secant line from P to Q2, I'm just going to do this all in my calculator. So it's going to be 650 minus Q2 was at 310. So 650 minus 310 divided by, it took 20 minus 12.4 seconds to do that. So again, what I just did, it's just simply change in distance over change in time. And again, that's just your slope formula, right? Rise over run. We're finding the slope of this line, rise and run. Here's the rise, here's the run. So anyway, this is approximately 44.7. So we're going to say 45. Oh, and then I wrote 54. We're going to say 45 here. Can I just skip these? I guess I can't. All right. Again, I'm just going to do this one real quick. So 650 minus 554 divided by 20 minus 18.1. It's 50.53. So I'm going to round that to 51. Which makes sense, right? You slam on the gas, so he starts off just a little bit slower, and then he's getting faster as he goes. So the average on the whole thing was 39. This is kind of just the second half is 45. The last third is 51 meters per second. And then that very last stretch, 650 minus 599 divided by 20 minus 19. So notice this is the last second. You see that? In the last second, he was, oh, that was 51. Oh, duh, divided by 1. So that was 51. So in that last second, he was going 51 meters per second. Essentially, notice as the intervals, the Q1, Q2, Q3, as we get closer to the point P, we're getting closer to how fast he was going at P. So that's kind of the idea. So then part B says, what is the order of the slopes of the secants from least to greatest? Oh, well, it was the order we just did. 1, 2, 3, 4. That's kind of strange. The end of it. If there were a question now that said, so estimate his instantaneous rate of change at point P, we would probably estimate it to be 51, since it kind of seemed to even out there at the end. Oh, I guess I didn't finish the question. Oh, continue. What is the appropriate unit? This was meters per second, right? Distance over time. Oh, how have I still not finished? Oh, goodness gracious, you guys. Okay, make sure you keep reading. Oh, it skipped it. Okay, so that last question was actually what I had mentioned. So kind of estimate how fast he was going at point P, and I would estimate 51 meters per second. All right, so this is just like the one that we did in class. So first it wants us to plot the points. So notice this is just the year is considered the X value, right? Time on the horizontal, he's independent. And then the profit depends on the year. So the profit is the Y value. So just plotting these, we would have the point 210, 205. That is not him. 210, 205. That one looks about right. That one looks about right. That one is not right. Okay, so it's B or C. Let's see. 2011, it was at 226. That looks like 250, so definitely B here. So notice it's got a nice little slope to it. So in part B, what it's going to ask us to do, I'm going to go ahead and make this a little bigger. So in part B, it's going to ask us what the average rate of increase was between 2013 and 2015. So again, remember that keyword, average. That wasn't a very good highlight, was it? Keyword here is average, which means draw a secant line. And again, a secant line is just a line that joins 2 points on a curve, essentially. So 2013 to 2014, we want to find the slope of that line. Now notice that's a straight line. The curve is technically, well, curved. So if we want to try to average that, it's just slope. We just want rise over run. So what was the change in profit from 13 to 14? Let's just get that from the chart over here. So the change in profit was that, and change in year was just 1, change in time. So it went up by what, 63? So in other words, $63,000 per year. Okay, so from 2013 to 2014, on average, there was an average rate of change of 63,000 per year. And then C says, use your graph to try to estimate what was happening in 2011. So notice it's a single year there. So what they want us to do is try to find the slope of not the secant line, but the tangent line. So I really want to make this even bigger. I don't know, is that a little better? So what we want to try to do here is see if we can find the slope of the line at 2011. So it's the tangent line. Remember, a tangent line just hits at that point. So what we can do is we can, like I just drew the tangent line, you could kind of try to count rise and run there. But what I like to do is just kind of average the slope of this secant line and the slope of this secant line. And then if I just take their average, it seems like that's kind of close to the tangent line. So that's what we're going to do. So let's just find what was the slope from 10 to 11. Well, it was 226 minus 205 divided by 2011 minus 2010. So that is what, 21. So the slope there is 21. And then for the next year, so from 2012, between 2011 and 2012, 261 and 226, the slope was whatever, okay, 261 minus 226. So that's a 5. So 35. So I think that was 35. So I'm just going to average them. So 21 plus 35 makes 56. And then I'm just going to divide that by 2. And that would be what? 28. So I'm going to guess about 28,000 per year at 2011. All right, so that's my guess. Let's see what happens. So again, if you can find the slope of the tangent line, that's really what you need there. Notice this does, see the way that's written? Make sure you put the 63,000 in there, because it's just written as dollars. And then we decided to average it to be, darn it, what was it, 28? Oh, so that worked. So that was nice. And that is the last question, right? I'm going to just go back to that number 4 that I didn't answer part of. That was, it just asked kind of, what would you estimate? Yeah, so the speed, like I said, it seemed like it was really evening out there. So it was 51 from Q3 to P, it was 51 from Q4 to P, so it seems like it evened out. So I'm just going to go with, and that's meters per second. It's not meters per square second. That would be an acceleration, right? This is just meters per second. There we go. Stop.